Moro! Olisiko teillä hetki aikaa puhua meidän bioMARS-ryhmästä? All right. We were selected to NASA's Epic Challenge Joensuu in the summer of 2015 and started to work in autumn when we got to know our team-based challenges. At some point in November, we elaborated our challenge to be to develop an Earth-independent food production capacity increasing system, but between friends, it's a greenhouse for Mars. But hey, who are we? bioMARS has a chef, an architect, a photonics student, a designer, a media student, a biologist, and 2 high school students. Also a PhD student who now teaches this course. That's 8.5 brains plus the internet, working on solving this problem. Most of autumn was used for information searching, comparison between ideas, brainstorming, and a lot of reading. The amount of new information felt overbearing at first, but when figuring out the big picture, it all seemed to make more and more sense. You could also always ask for help from other team members. When we had figured out some ground rules and limitations for our system, it was time to ponder some concepts. By Christmas, we had over 100 of those. We decided to pursue 3 of those for testing, and then came the experiments and the year 2016. We experimented on fiber optics for illumination and sturdiness, growing single plants in tubes with variety in plant to light source distance, and also growing and cooking insects as food. During spring semester we also tested which diet fitted our crickets the best. Results show that in small growing spaces the distance between plants and lamps should be kept the same, meaning that when the plant grows the lamp needs to move up as well. When surveying the idea of insects as food, it was clear that only the idea of eating insects is hard to overcome for us Western people. When people actually tried our insect foods, the main opinion was positive. We tested the insect foods at our media event Mars Racer at the end of February, and the event was a success. Our main sponsor from there on has been EntoCube, that provided us with insects for Mars Racer and for our full prototype tests. We've been in close collaboration with Arcus's offices as well, as they developed our virtual working environment where most of our information sharing and documentation took place. In Finnish, we have a common saying, ei kukaan ole seppä syntyessään, which is roughly translated to no one is born professional. Our team members had to teach each other's fields of knowledge to one another, and due to that, a great part of conversations were productive. We all think in various ways because of our different backgrounds. Our final prototype combines plants, algae, insects, and astronauts. Because ISS astronauts have mentioned taking care of plants while on space missions to be meaningful for them, we wanted it to be possible to some extent with our solution as well. The algae and plants combination produces much oxygen, which can be circulated for astronauts and insects, the both of which also provide carbon dioxide in exchange and provide manure to be used as fertilizers. This concept can be utilized in different scales and outer appearances, when the balances between gas exchanges and nutritional productivity are fixed. Prototype-related work was mostly done in the University of Eastern Finland premises. The last 9 months have been busy and stressful in the best possible way. and being participants in this kind of NASA project is a great honor for all of us. Thank you NASA, and considering our awesome concept for Mars, you're welcome.